learning series on vamsivisions. A big thanks for all of you for your support on my 50th episode last week. It gives me more motivation to keep creating and sharing videos to you all. Now let's jump right into the video. Did you know that we use two forms of electricity every day? One of the forms is alternating current or AC and the other form is direct current or DC. DC is what you would use for your mobile phones and your TV remotes. You might be wondering why AC current is different from DC current. Well, in simple terms, in DC, electrons flow in one direction, but in AC, they change direction. Make sure you all watch till the end, as I have a few simple electrical circuits and a flashlight demo to show to you all today. Alright, without further ado, let's get on with it. To start off with, we have three main parts. The battery, which is the source of energy, the LED, which is an object for the circuit to power, and these two copper insulated wires, which have clips on the end of them, and these are the conductors. I'm going to connect everything together to make a loop called a circuit. Electricity flows around the circuit and makes the LED glow. Look closely now. Now I'm going to attach the copper wires to the battery and then to the LED. Now I'm going to connect this wire to the LED to complete the circuit. And as you can see, it's glowing. Now I'm going to hook on different objects to see if the circuit still works and the LED glows. Now, as you can see, I've connected the pencil to the circuit, and because a pencil is an insulator, it's not allowing the LED to glow. So this is a key, and the key is a conductor. So when I put this on the LED, it should glow. This is a book, and obviously this is an insulator. It does not conduct electricity. So when I put this clip onto the LED, it should not glow. So as you can see, it's not glowing. This is a coin, and a coin is a conductor. So when I attach this clip to the LED, it should glow. These are just a few of the ones that I could think of, but the options are endless. You can try this for yourselves with whatever you think of. This is the salty circuit. I've used the same components as the previous experiment, except I've added this glass of water with some salt in it. Okay, let's see what happens when I attach this clip to the LED. Now I'm going to attach the clip. Wow, would you look at that? The blue LED is lighting so brightly. Adding more salt to the water increases the number of ions the water contains, meaning that a high number of ions are free to move and conduct electricity. Therefore, a stronger current can pass through and the bulb glows more brightly as a result. This is the circuit I made using 3 lemons, 3 copper coins and 3 silver coins. Inside the lemon, the ions complete the circuit in a similar way to what we looked at before, which also produces current. A chemical reaction strips electrons from the copper coin. These electrons then move towards the silver coin, producing a current. Now I'm going to attach the clip to the LED, and if it glows, that means the current is flowing all the way through these lemons to the LED. Let's see what happens. Wow, it's actually glowing after it's gone all through these lemons and to the LED. As part of the test and tweak, I'm going to be using 2 batteries and a 2.5 volt bulb. Now, let me get on to showing you the circuit diagram and the steps on how to make the flashlight. So this is a diagram of a flashlight. And this is the light bulb, this is the switch, and these are the two batteries. The arrows indicate the flow of current. First, cut the neck of the empty bottle, then line the inside with tin foil. This will be your reflector for your flashlight. Next, make a hexagon box and attach the two wires as shown. Now, tape the batteries together and make sure the positive and negative terminals are touching. Then, tape the end of one wire to the bottom battery, then insert both the batteries inside the hexagon box. Now, as you can see, I've put both the batteries inside. Wrap the end of the second wire around the bottom of this bulb, then attach the bulb to the top of the battery and secure it with modelling clay. Now I've attached the bulb to the batteries and I've also added the reflector. Now the flashlight is ready and I've also decorated it with some stickers. Now as you can see, our handy, useful flashlight is ready. Since the circuit is open, there is no current flowing through it. I'll close the circuit now. As I do this, the bulb should start glowing. Wow, look at that bright light. The light produced by the bulb is reflected by the foil and in turn it emits a bright light. You might think electrons zip through wires at blinding speeds, but they actually move no faster than a snail. However, the energy they carry does move incredibly fast. Like the billiard balls colliding, electrons transmit energy by pushing each other along, though each one moves only a tiny bit. I refer to Robert Winston's Science Experiments books and Miles Kelly's Super Science Experiments book to make all these experiments. I hope you all enjoyed watching this electricity video. I recommend you to watch my early STEM videos if you are interested in what you've seen today. I will leave a link to those videos in the description box down below. If you want to participate in my future STEM episodes, you can send an email to me at stem@vamsivisions.co.uk and I'll reply as soon as possible with the next steps on how to get involved. So what are you waiting for? Drop me an email to exhibit your STEM passion and skills. Also visit the vamsivisions website at https://www.vamsivisions.co.uk to know further details. All the information is listed on there. Please like this video and subscribe to Vamsivisions to show your support. And on that note, I'm signing off today. I'll see you all in the STEM episode next week. Have a good day everyone. Bye!